Hey everyone. Okay, so this is hopefully a quickish tutorial to go through some of the final steps in a model where we started with our bears data, created points from them, created lines based on the points, and then intersected the lines with the streams data, which in this case is a line file, so that we can ultimately get point information of all of the different stream crossings. And Ian in class today asked a really astute question, which was, at the output of this, I can count up all of the points, but that gets kind of, like if we wanted to know how many stream crossings there are for each of these different animals, but it would be really nice if I could have all of that information in a single shapefile so that I can just summarize at one time to get the count of all of those points for all of the different animals. So if we want to get there, then we need to think about how we want that final data set to look. So ideally what I would want is all of these point data layers, the stream crossing points, for all of my different bears together in a single shapefile. But if I want to be able to summarize based on or summarize the counts of each of the stream crossings, then I need to have an attribute in that field that tells us which bear it's associated with, right? Otherwise, if I just count up everything, I'll just get the total number of stream crossings for all of the bears, but I want to be able to separate for the individual bears. So to get to that point, what we need to be able to do is to add an attribute, basically, that has the information associated with the name of the bear. So that's what we're going to do. But before we get there, I did a little bit more deep dive kind of thing into this process. And I realized that when you output this stream crossing output from the intersect, it comes out as a multi-point point file. And so what that means is that anytime you have a multi-point or a multi-line, I don't know if there's a multi-polygon, probably. Anytime you have something that starts with a multi, then basically it means that there could be multiple points or multiple lines associated with a single row of attributes. So here's an example of how that might happen for for the streams versus a line of the bear movement, right? So imagine you have a stream that looks like this, and then your bear movement goes from point A to point B, right? And so you end up with a straight, imagine that's a straight line going through. Here you end up with one point there and another point here, both of which are associated with the attributes of a single line and a single stream location. So when you do that final intersect, these 2 points in a multi-point output actually end up as a single row. And so if you count them, as in terms of counting up the number of rows that you have in your output table, these 2 points will actually only get counted as one row feature. So that is one other, oops, I didn't want to stop my screen sharing entirely. Let's go back to the screen share. So that is one other thing that we need to deal with before we actually get to adding the attributes. So there's an easy tool, it turns out. This is all new to me. There's a tool called Multipart to single part. So let us add that in. And this we can apply and should apply, I think, before we start messing with the attribute tables and adding things. That probably will keep things a little bit simpler. You'll notice also, if you recall in class, one of the other things we did was to split the line at the vertices. In this case, because I am going to do this multi-part to single part at the end, and because my output is points, there's not really a need to split up the line. I can just have a single line and another single line, find all of the places where they overlap, and as long as at the end point, I split any of those multi-part points into their single point component parts, then I should be okay. And this, just like anything else, is going to be, yikes, my name, percent name, to go to call it whatever my bear is called, and stream, I'll call this single. Okay, so hopefully that's going to work later on. Now, this is the thing that this output, my single point stream crossings, that I want to add my field that is specific to the names of the different bears. Add field, I believe, is just called add field, so that's pretty simple. And we need to tell it what's the name of the field and what type of field is it. So I'm going to call this bear name. Remember that the names of the bears, so these like names, right, were like MR0802. So that means that it has both text and numbers in it. It's alphanumeric, which means that it can't be an integer, right? Because an integer is just 1, 2, 3, 4. That is some form of text. Field length here is how many characters of text we need. To get MR0802, we need 6 characters. I'm going to just play it safe and give us 10 characters to work with to write into that field. Let's go over here. So now this is that same stream cross single points with an added field associated with it. And then just like you would do within your attribute table, you can calculate field. There it is. Your field calculator, and connect that guy up. So this should allow us, hopefully, to find our bear name, which should be all the way at the bottom, because remember, anytime GIS adds a new field, it always adds it to the very end. And anytime you're looking for field names, the very end is going to be at the very bottom of the list. Okay, so here's where we get fun. So the way to read the field calculator is bear name equal to whatever I'm going to put in here. And all of this stuff is like options that I could put in here. But in this case, actually, all that I need is my name, which is, as you recall, percent name percent, right, refers to the variable name that the iterator is going through. By putting quotes around it, we're telling GIS that we want to treat this as a text string. Anytime you put a text string, you want to put double quotes around it. I do not know why it's red, but it seems to work. So I am going to validate this whole thing. I'm also going to like make a nicer layout with it. It's getting a little unwieldy, hard to read from that end. But this is, let's see if I can make this go away so you can see a little bit more of it. That looks pretty good to me as far as a nice iterator that will get me to an endpoint where I have a whole bunch of files called name stream cross single points that I'm eventually going to merge into a final file. Okay, so I'm going to pause this while this whole thing runs. So there's nothing quite like going, next door for a couple of minutes and coming back and finding that your model has completed correctly, which I hope happened to you. That didn't, of course, happen to me. It crapped out in the middle for no particular reason, and I had to restart it. I restarted it. It died at bear number 13, so I restarted it again by adding that wildcard to my iterator to start with like bear. This actually went back a step and started with 10 rather than 13, but that at least started it halfway through. So if yours dies in the middle, hopefully, since the numbers are sequential or something like that, you can tell it where to start again. Okay, so now we need to go back over to catalog, pin that so we can see everything. And here is all of our output files. Refresh these just in case anything's missing. And let's bring those guys into Newfoundland. So we should see let's just visualize these so that we've got, there's our line, here are our streams. Maybe I'll make those blue or something so they're a little bit distinct. And I'm going to zoom in so it doesn't have to draw so many streams. So there's a bunch of streams, there's a bunch of lines, and here are our stream crossings associated with those. So hopefully anytime we zoom into any of these, we will see that it's a location where our bear track crossed one of these streams. And hopefully also when we open the attribute table, we will find that, still says it's multi-point. We'll find, not in the stream crossings. Stream crossings, single point is what I want. Where'd it go? Not that one. That's probably why it says that it's multi-point. So hopefully this one will just say point and not multi-point. There will be a lot more of them. And if we're lucky, we will also have bear name appended to this one as well. So if you did this one before, you'll notice like the stream crossings, right? So this is the one where we just, let me open the attribute table of that. This is the one where we just intersected the giant single feature bear track line, so that wasn't split up, with our streams. And you see that it ended up with 658 multi-point features, except that a bunch of these, if we look through carefully, we would find that a bunch of these, points are actually multiple points associated with them. So if we just counted up all of the rows, we would get 658, when in fact there are 1965, quite a bit more actual stream crossings. And I was playing around with this a little. You still don't get this high of a number. You get like 1800 or something like that if you split all of those bear lines by vertices, because there are just going to be a couple of places where a single track from, point 1 to point 2 crosses a curvy stream, a couple of times. So that happened enough times that it throws off your number slightly. Good. So single points with our bear name appended to it. I'm just going to remove these because the last piece that we now want to do is to merge all of these stream cross single points together. So merge is called, the tool for that is helpfully called merge. I don't need to do this. I don't want to do it inside of modelbuilder because I'm only going to do it one time, and I'm going to do it for, I need to go find my, browse through and find all of my ones that are called single points. I'm on a PC, so I'm going to use the control key to select multiples, hold down control and click on all of the ones that I want so I can bring them all in kind of at once. Okay. And then I'm going to call this, yikes, all bear stream crossings. Good. There's going to be a decent amount of junk in this final merged data set, but because all I care about is the count of the number of points associated with each bear, as long as I still keep my single field called bear name, and there should be just a single field called bear name because we called it exactly the same thing when we created each of these files. As long as I have that, that's all I need to summarize the counts. So let us see. So mess, things we don't understand. Bear name, yay, right? Bear name is in here. I've got tons of points. I should have, if I scroll down, different bear numbers, right? So, or bear names, I guess, associated with these. So how do I count up however many single points of stream crossings there are associated with each bear. That should be pretty familiar to you at this point. My case field is bear name. Doesn't matter what you pick over here because we only care about the count. So for any field, the count is going to be the same of how many rows there are associated with each unique bear name. And if I were smarter, I would have named this something more intuitive, but now I have a nice table of all my bears and all of the counts. In this case, frequency and count are the same exact thing, telling me how many times each of these bears crossed a stream while they were collared. So hopefully that will help you do those final steps in terms of processing for your mountain lion data. And I will see you in class next week.